Well, I've been busily chipping away at my next experimental E-field beam antenna. Now, if you've watched my previous videos, you'd know that the previous E-field beam antenna had toruses or tori. So, like this sort of thing. So here there was, let's say, a torus and a torus. And then a bit further away was this bigger torus and a bigger torus, okay? So what I was trying to do with this one is to get the same advantageous effect that I get from the torus, but in a flat plane like 2D. Now I'll try and explain that a little bit. One of the great advantages of a torus when it comes to E-field systems is that unlike when we view current, in an instantaneous point, let's say if the center becomes positive, instantaneously across here is negative. So we have E-field lines across that way, right? And any current that tries to get from where it started as positive to this negative goes both ways, which cancels a TEM wave initially, and we just have the E-field vector outwards in all directions. So with this, for example, when this point becomes positive in an instantaneous sense, without these sections here, it would have automatically made this negative before current got there. And current would have to go both ways to get there. Now what I've done is I've added sections in between too. So if this was positive, which would have made that negative, positive makes that negative, makes that positive, makes that negative. But we also have more of a continuous path to encourage the E-field lines in these directions, and of course discourage in those directions. And same here, and here, and here. So the system's evolving slowly. It now has 3 different dielectric inductors. The first one basically prevents some of the back EMF, captures what would be back EMF and re-adds it for forward. The next one is what I call a regenerative system, or the feedback loop. And then the next one actually just allows for differential. And this is, of course, it's run out here, but this is where it gets really interesting. This is a symbiotic pair of 3-plate dielectric inductors, and these work in a manner where whatever this one's doing, it forces the other one to do the opposite, because they're interconnected and they cannot behave the same at any given time. They have to be opposing. So so they're really a critical part to the system. As you see here, I've got a gap because I'm planning on adding another set of these in here just to see if it really improves the scenario. And this is another dielectric inductor that is kind of like imagine just having a high value coil across the 2 sides, but it's not a coil as such. Anyway, this is kind of freaking me out, all right? So I'll just move it a little bit and I'll show you what I mean. It's kind of freaking me out. So I've got it hooked up to the radio. So what I'll do, I'll go from 10% first. I'll go down to 1% on RF power, which is 100 milliwatt, okay? I'll go to CW mode and I'll just start a beacon macro. Right, now, so she's transmitting. I'll just show that again. Oh, hang on, where's that button? Right, 1% RF power through the ATU. Now, I'm going to come here. Now, it's a shame I don't have a wide angle lens. Now this magic wand detector, of course, has LED lights on it, it takes a fair bit of energy to light them. Now I'm off the side here. You can see they're lighting when I get very close. I'm interrupting the field. But I move a little bit away and they're hardly tickling. So I've not got much room here, but right, I'll come off to the front. Look at that. They're lighting really, really well. And this is 100 milliwatt. 100 milliwatt. A tenth of a watt. Which is just insane. Okay? So from another perspective, I'll grab the 50 microamp meter that has LEDs across it. So you can see off the side, yeah, getting a reasonable tickle there. I have to move over here now, off the front. It's banging. I haven't got a lot of room in here. A little closer, it's even lighting the lights. And this is 100 milliwatt. So, I haven't got a lot of room here. This is not ideal testing in this spot. Off the back though, it's very soft. So I'm getting the same sort of pattern behavior as my previous version, but I've managed to succeed on kind of 2D element system to direct the E-field vectors. So, what I'll do now, I'll just grab my little magic wand again, but this time I'll take it all the way up. We'll go QRO here, right? Let's see. Hopefully I get this to focus. It's a pain in the ass, isn't it? All right. Where's 10%? 10%. I'll just make sure that's shown. So now we're at 1 watt. So I really went QRO, okay? So 1 watt. It is tickling. All right, and now I'll just come around the side. Tickling quite bright. And now, sort of off the front, absolutely nuts. 1 watt. So, yeah, it's kind of freaking me out, because you wouldn't assume that to be possible, would you really? How can that be possible? I'm lighting these LEDs so well wirelessly, and it's only 1 watt. Go figure. All right, now, sorry I'm not very good at videos. I'll take this up to, we'll go mega QRO now, right? All the way up to 50%. So we're now at 5 watts. So this is, insane power levels now. So it's actually lighting up quite a bit at the back here. Now, of course, there's lots of disruptions in this room, so it's non-ideal. Okay. Now, sort of off the front. Absolutely mental, isn't it? My God. That is just totally bonkers. So, I'm probably causing myself eye damage here. But there you go, 7.3, and thanks for watching. At least with this one, I should be able to put it up on a rotator. Click like, maybe subscribe, and stay well.